611, divide fractions by fractions. So we just went through this here. It went well. No issues whatsoever. Multiply by the reciprocal. And that's going to continue to be true. All these are going to be multiplying by the reciprocal. So page 218, again, there's all the rules. We don't need to write them all out again. We did that yesterday, more or less. So looking at page 219, lots of problems. There it is, 219. 219. Number 7, right at the top, 1/2 divided by 1/6. And again, the 4 magic words. Multiply by the reciprocal. And there it is, right there. So, same magic words as yesterday. So, reciprocal, 1/2, you don't touch the first fraction number. When it was a whole number, we just made it in fraction form, put it over 1, but this one's already in fraction form. We don't have to fiddle around with it at all. And here we go. Division becomes multiply. Yes, it does. Multiply by what? The reciprocal.
So always the second number is reciprocal?
Right, always the second number. So the reciprocal of 1/6 is 6/1. Now it's all set as a multiplication problem to solve. Cross simplify if necessary. Multiply the numerators, multiply the denominators, simplify if necessary. Final answer is 3.
I told you I know how to do this.
Right. So once again, 1/2 divided by 1/6. Rewrite as a multiply problem, 1/2 times the reciprocal. Reciprocal of 1/6. Denominator becomes a numerator. Numerator becomes the denominator. There's my reciprocal. Solve the multiplying problem. Yes? I'll do 2 more. I'll try number 19 and 27. But you try them too. I'll walk through them. Doesn't take long to do them. Fast problems. 3/4 divided by 3/8. 7/9 divided by 5/6.
Now we're doing 19, 27.
Remember to write out the problem in your notes. Write out the problem, and then solve the problem.
Do we, so I have to write down the answer?
Yes,
You
yes.
Write out the problem and then solve the problem. Otherwise, it's just numbers. There's no context to what any of them mean if you don't write out the problem
To
here.
me, that's the dumbest question I've ever heard.
But do I have to write down
Yes,
anything
you
to
are
say?
good.
Right, you write out the problem. There's not that much. It doesn't take that long to write 3/4 divided by 3/8. It's not like
Then you have to
Tons
go
of
through
writing
technical stuff. The technical stuff.
all the technical stuff we went through yesterday, or at the start of the chapter when we learned how to multiply. There's nothing. The rest of this chapter, this is all we're gonna do. It's just you guys getting more repetitions. And you guys need the repetitions. I mean, just the cross simplifies, all the things, getting used to it, how it works. You're getting much better at it. But it's your basic math skills too, which again, you guys need more practice with that. So you get to work on multiple different good things. Yeah.
Yesterday, when we were doing divide whole numbers by fractions, but if the whole number is in the right side, then do you change that one into?
Yeah, that's our next lesson coming up here, but you are right. This would just be 2/3, again, divided by 50/1 would be 2/3 times 1/50.
So it's always the second.
Always the second, right. Just like reading a book, multiply by the reciprocal, just like reading a book, left to
So
right.
it'd be
Multiply
1/3.
by the reciprocal.
It'll be 1/50.
Right. 6/7 times 1/42.
I'm
6/7 times 1/9. Because same deal. We'll write them this way, but then we're multiplying by the reciprocal. Flip a root. Right. So that's what we're going to do on Monday, Stella. Let's see. But I kind of think you already know how to do it now. I've like given away the whole lesson to you. Right. Question?
What problems are we doing?
I'm about to do 19 and 27. Here we go. So 19, 3/4 divided by 3/8, rewrite as a multiply. 3/4 division becomes multiply. The reciprocal of 3/8 is 8/3.
That's great.
Cross simplify, the 3's become 1's, the 4 becomes a 1, the 8 becomes a 2. 2/1, final answer, 2. 27, rewrite as a multiplying problem. 7/9, division becomes multiply. The reciprocal of 5/6 is 6/5. Cross simplify the 6 and 9, greatest common factor is 3. Simplified as far as it's going to go. 7 times 2 is 14. 5 times 3 is 15. 14/15. Yes?
Yeah.
Think you guys can do it?
Oh yeah. Absolutely, this is easy.
You're in? Okay. All right. 1, 2, 3, 4, 5, 6, 7. First 4 problems. Try number 14. 3/14 divided by 1/7. Number 18. 4/9 divided by 1/12. Number 22. 7/10 divided by 7/20.
Are we doing 50?
26. 14, 18, 22, 26. 14, 18, 22, 26. These right here in the book.
3 problems? 26? Oh, okay.
14, 18, 22, 26. They're right in a row there.
Boo!
Usually that's how I do it. So those that are looking at the book, it's easy to find.
Yeah.
I just usually grab a row and I just go down most of the time. Yeah, 14, 18, 22, 26. There they are.
What's the last problem that we do?
26.
Yep. 14, 18, 22, 26. 4 problems. Round 1. Round 2, 3 problems.
Round one. Fight. So it's round one.
It's not starter.
Yeah, it's fight. Round one.
Michaela, which one do you want?
26.
You want 26?
Yeah.
Okay. So when you set it up, how do you write it as a multiply problem?
Kind of like a fraction.
What would I write? Yep. So what's this
4
fraction?
7
Yep. Times?
times 3/14.
Nope. We gotta remember when
Oh.
you gotta switch them around.
14 thirds.
Right.
I keep doing that.
That's okay. Right.
But can I work on the other problems?
Well, this one you're gonna do for us here. So why work on this one first? Or do you wanna do a different one?
26 is fine.
Okay. So now we got it as our multiply there. Can you cross simplify?
7 times 14.
7 divided by 7 is?
1.
Yep, and 14 divided by 7 is?
2.
Right, so now I got a 4 and a 2 on top, and a 1 and a 3 on the bottom. Okay?
Yes, thank
Okay.
you.
Yeah, I'll check back. All right, here we go. 14. Ella's not here. So, okay. George, 18. Stella, 22. Roland.
Okay, I'm fine.
And Michaela's doing 26. All right, George, you ready?
Yeah.
Okay, write it out as a multiply problem for me.
Okay, so it's 3/4 times 7 is 1.
3/14.
3/14. So now, okay, so then the 7 divided by 7 equals 1. Then 7 divided by 14 equals 2. 2 times 1 is 2. 2. Then 3 times 1 equals 3. Then that would equal 1 and 1/2.
Right. Perfect. Just like that. What?
I just want to make sure I did. I'm supposed to be multiplying, right?
Right.
Okay.
4 times 2, there's your top. 3 times 1, that's your bottom.
Okay.
Okay, Stella, you ready?
Number 18.
Yes. So as a multiply problem, what do I got?
4 notch times 12 over 1.
Right, good.
And then you can cross simplify so then the 9 becomes a 3 and the 12 is a 4.
Mm-hmm.
And then that's 16 over 3. And 3 goes into 16 5 times. So 5 and 1/3.
Right.
That's stupendous.
That's it, right there. 5 and 1/3. That's what we need. Good work. Well done. Roland, you ready? All right, write the multiply problem for me.
7 over 10, 20 over 7. 10 goes into 21. And then, 10 goes into 20 twice. And 7 goes into 7 at once. And then this is the hardest part ever.
Right. Think it through,
Two.
Roland.
And then 1,
Right.
maybe, that equals 2.
Bada bing, bada boom. He's got it. Good stuff. All right, Michaela, what's 4 times 2?
I'm kind of stuck.
What's 4 times 2?
4 times 2 is 8.
So that's what I got on top. On the bottom, I got 1 times 3.
3.
3. And then if we turn that into a mixed number,
8 thirds.
so I could set up a little division bar. How many times does 3 go into 8? But not too many.
4.
Well, how many? 3 times 1 is?
3.
3 times 2?
6.
3 times 3?
9.
So how many times does it go into 8 without going over? 3 times 1 is 3. 3 times 2 is 6. 2 times 3 is 2. And how much, what's 3 times 2?
3 times 2 is 6.
And how much do I have left over?
3.
2.
I mean 2.
So now, the answer up here, that's my whole number.
Yeah. Big 2.
And whatever I have left over is my little 2 over there. And my denominator, whatever I used here and here, doesn't change.
I did 1 times 2 is 2, and then I did 4 times 3 is 12.
1 times 2 is 2, and 4 times 3 is 12, but
I had to do that all.
So that's wrong, right?
I think so, yep.
Okay.
That would be what we get. We should get 8 over 3, and then turn it into a mixed number and get 2 and 2/3. All right, last 3 problems. So I'll give you a couple of these compares here. give you number 36. So that means, once again, solve both sides.
Or easier.
And then I'll give you a word problem. And then I want to,
Yours is get that word problem.
time permitting, I
Yeah.
want to kind of go through something else with this concept that's not really in the book with you. But I'll show you. Let's see how this goes. So, and
Apologize to everyone. You are an apology.
You are an apology.
number 42.
42?
Yep. Word problem right there. Karen divides 3/4 cup of salad dressing into 1/8 cup portions. How many portions of salad dressing does she have?
A bunch.
Right. So 36, 38,
And 42.
and 42. Right. 36 and 38. Both of those you got to solve your two problems. Then you need to compare your fractions. And you can do that one of two ways. Write them with common denominators and compare the numerators. Or you can use cross products. Two.
I really don't want.
Why?
Because that's right problem. Yeah, that's right.
Yeah. Oh yeah. Yeah.
If I did it, I will tickle you.
That was so random.
You guys all done?
No.
Okay, well, let's finish up our work here
Like, is that a good thing or
first.
That's a good thing.
bad?
Guys, just finish the work. Make sure you're in good shape here. So you can have a good quiz on Monday. And again, we're gonna look at something a little different after this here that's not in the book. Question?
For 46 and 48,
Yep.
do you, for like the seconds, do you do the problems closest to where you'll put your symbol? Or,
Well, you're just solving these two problems and then comparing those two answers against each other.
okay,
To compare the answers, though, you have to either rewrite them both with common denominators, figure out what the common denominators between your two fractions are, and then you can compare the numerator, or you can use your cross products method to figure out what's greater or less than something else.
Honestly, I don't.
Cross products is usually the more effective solution. Okay. There we go. 36, Uriah. 38, Noah. 42, Lauren.
Still take
Please.
I wait, did George do one already?
Yeah.
Oh, I don't remember.
All right. Any of you three ready? Noah?
I
Uriah, you're ready? All right. Well, you're up first, Uriah. Then. So rewrite this as a multiply problem.
1/5 times 7 ones,
Yep. And that equals.
7/5.
I'm just going to leave it in that form for the moment. So now let's go to the other side.
1/8
Yep.
times 9 ones, which equals 9/8.
All right. So now, do you want to figure?
Now you can simplify both of those answers. They both have a 1. They both equal an overall total of 1.
Yeah.
For 7/5 turns into 1 and 2/5.
Okay.
9/8 turns into 1 and 1/8.
Okay.
The answer 1 and 2/5 is greater than.
How do you know? How'd you prove it?
Huh?
What's your proof?
My proof is that 1 and 1/8 is smaller. So it's split up into more parts, which makes each one smaller. And the overall number is smaller. The numerator is smaller.
Okay.
Or you could just say that
Right.
1/8 is.
I'll go with that. But
farther away
if
from
proof is indisputable, undeniable evidence of. So I know what you're saying here. But again, I would rather prove it with common factor. And I can leave, I don't necessarily need to do this step here because again, I still have to compare these to each other, whether it's 7/5, 9/8, you know. So my two choices would be to rewrite with a common denominator. What's the common denominator between 8 and 5? It's the least common, right. So then 5 times 8, 7 times 8, I got 56 over 40. Over here, 8 times 5, and I got 45 over 40. Yes, now they got the same denominator. I just compare the numerators. 56 is greater than 45. That's proof right there. That's undeniable proof right there. Or, I said again, it's one way. The other way you could have gone about proving it is using your cross products method. And what you do is you take this number here, this numerator, multiply it times this denominator. What's 7 times 8?
7 times 8 is 56.
So I
And
got-
they go to back one.
We're almost done. That's on the left, and on the right side, Uriah, pay attention because again, you weren't able to justify your proof here. So I want you to learn how to do this. 5 times 9 is?
5 times 9 is 45.
Right. And again, I'm writing above the numerators, but these two numbers here, this is the other way, undeniable proof. So again, I know what you're saying. You're kind of mentally conceptualizing that 2/5 is greater than 1/8, and that's cool. But if I put something like, I don't know, 3/19 and 5/23, that might be harder for you to conceptualize, like which one of these is greater or less than, right? So then you're going to need a better method. And you're better, this one, again, I wouldn't try and figure out the common denominator. I'd cross products. 3 times 23 is 69. 19 times 5 is 95. 69 is less than. It's less than. 3/19 is less than 5/23. There's my proof.
Okay.
Okay? So, all right, yeah, you can go to the bathroom. Okay.
I'm not sure.
What?
There's another way you can solve that.
What?
3/19 and 5/24. So I usually like to go which one's closest to one whole. So you could just do 3 minus 19 and 5 minus 24. And which one's?
Again, as the numbers get even larger still, like if I put something in the millions and then something with a little more millions and changed it, that wouldn't prove true. I know what you're saying here, but the numbers are so small that when we subtract, it's a greater difference. But if the fractions and the tops and bottoms were much bigger numbers, your strategy, you wouldn't be as much difference between. Does it work that way? It would be such a small, small, small difference between. But I know what you're saying. It wouldn't work with really large numbers though. So, no, again, back to, again, the cross products or the common denominator. That's your two choices. That's just how you do it. Later on, again, we'll learn how to convert these to decimals, and then we could compare their decimals against each other. But that's coming up here a little later this year, so we'll have another tool. Okay, Noah, 1/8 divided by 3/4, how do I do that?
So you have to rewrite, the 1/8 and then 4/3.
Right, rewrite as a multiply, okay?
And then you can do the cross out thingy with the 4 and
Yep.
the 8, and the 4 becomes a 1 and the 8 becomes a 2.
Yep,
So then it's 1 times 1 is 1 and 2 times 3 is 6. So you
okay,
have 1 6 on that side, and then
yep,
you have and then you have 1 9 times 3 2s, I guess, or
Yep, 3 over 2. Yep, 3
And
halves.
then the 3 becomes a 1 and the 9 becomes a 3. And then you have 1 times 1 is 1 and 3 times 2 is 6 again. And so then it's equal.
Right. Easy to make that comparison because they both conveniently show up with the exact same denominator for you. But for all I know, you could have got 2 12s or 3 8, on and on it goes here, but simplify if you need to. But yeah, this is good. 1 6 does equal 1 6. All right, Lauren, 42. Karen divides 3/4 cup of salad dressing into 1/8 cup portions. How many portions of salad dressing does she have? So set up the division problem first.
So the division problem would be 1/8 divided by 4. Would be divided by 3/4.
The other way around.
Yeah.
Because you take if the first number is what do I have? Like if I have 6 feet of tape, and I'm going to cut it into pieces. I take my 6 pieces, say I have an 8-foot board, and I'm going to cut it for the 8 of us. Well, I'll get a foot, right? My 8-foot board. So I take my 8-foot board. How much do I have? 8. I divide it how many ways? 1, 2, 3, 4, 5, 6, 7, 8. So you always take how much you have to start. And it says she has 3/4 cups. So that would be my first number because how much do I have? I got 3/4 of a cup. What am I doing? I'm taking that 3/4 of a cup and then I'm dividing it into little 1/8 cups here.
So then you would flip the 8 and the 1.
Yep.
And then you can cross simplify or with the 4 and the 8.
Yep.
And that would be a 1 and that would be a 2.
Yep.
And then 6.
Right. How many portions of salad dressing did she make? She made 6 portions. Okay. I'm gonna go through something else here for a little bit. We're not done.
Can we go to notebooks though?
No, we're gonna do more notes here. Another kind of, and what I'm gonna kind of illustrate is some of this type of stuff down here. But I want to show this in a slightly different way to you here. Will you necessarily be challenged on what I'm about to show you the rest of this chapter? Probably not. Is it easy and relevant and useful to understand to this where we are in this chapter? Absolutely. Uriah, turn around. Put your feet on the ground. I'm still teaching. I'm teaching you something that's not even in the book here. Using this as an example. So I'm going to write out this problem here. Again, I don't know what type of answer we're going to get. I'll just say that in advance to you here. Okay. I'm going to go 3/16 times 4/5 times 5/20 times, just to be contrarian, I'll throw 10/8 up like that. Okay. So kind of a chunky looking problem. Agree with that?
Oh, yeah.
Just to be even more fun, I'm going to put another one on there. There you go. Let's make it even more exciting. Right. 5 numbers, 5 fractions all at once. How could we ever possibly figure this out here? Is it even possible to do? Probably not. Right? No, it probably is. So, there's a lot going on here, isn't there? Cross simplify, how could that possibly work? If I wrote this all as one giant fraction, which I could do, I could certainly write it this way too, because we know that in a sense, when we do all these other fractions here, in the end, you just multiply all the numerators you have left together then you multiply all your denominators together, right? But in our case, there's always just been 2. This times that, this times that. But I could multiply certainly more than one number. Now, what I'm trying to illustrate and show you here is some of how cross-simplifying can work. I can cross-simplify here, but I can cross-simplify any number on top with any number on the bottom. Any number. Any number. Which means, let's look for some cross-simplifies here, all over the place. Roland, you had your hand up first. What could I simplify with the top and bottom?
3 and 3.
The 3's can both cross out and be turned into 1s.
4 and 8.
Well, just one. I'll get let other people. There's a lot of them going on here. But I can do a cross simplify this way. This is okay. All these things. And same thing, if I did the same thing over here, wrote it all in one line, that's good. Stella, what's another one you see?
10 and 20.
10 and 20, what do they come?
It's a 1 and
A 1 and a 2. Right, 10 and 20, I can simplify those right there. What else? Somebody else besides Lauren, what do you see?
4 and 16.
The 4 and the 16 turn into,
1 and a 4.
or should I use this 4? Doesn't really matter. Which 4 should I use? This one or the second?
Closest to it.
Far one? All right, turn that one in, and 16 becomes a 4, right? What else? Somebody else. Noah, what do you see?
The 5.
The 2 5s. Well, they can both cancel out too. What else? Michaela,
The 4 and the 8.
the 4 and the 8, what do they turn into?
4 goes into 1 and the 8 goes into 2.
Right. This point here, I don't really think there's much left to simplify because look at my top. I got a 1, a 1, a 1, a 1, and a 1. So I think I've cross-simplified this thing about as far as I can possibly cross-simplify this thing, right? So what do I have for an answer on top? What's 1 times 1 times 1 times 1 times 1? 1. What's 4 times 1 times 2 times 2 times 1?
16.
And there's my final answer to this mega problem that we just had. And that was a mega problem, wasn't it? But just, again, you're not going to see anything nearly this complex here. But how cross-simplifying works, it's kind of nifty how it does work. Like if there's more fractions or things like that. The book here, like if they show, let's look at 45 here briefly. This is in your book here. And they said, solve this. Well, the one I wrote here, I just made it all as multiply right off the first place here. But we know that whenever we're dividing a fractions, we could rewrite it as a multiplying problem, right? So I would want to rewrite this. In all of these, I'd want to rewrite this, and I'd want to rewrite that too. Because we never divide fractions, do we? We multiply. So I would just want to simply rewrite this whole thing here, not divide by 3/4, but instead multiply by 4/3. And what they're trying to illustrate here, especially with this lesson, this is mental math. Mental math means you shouldn't have to actually write anything down. But what's my answer to all this right here? You should be able to see it without doing anything. 5, 6, because what's going to, remember, any reciprocals, the product of any reciprocals, these numbers are reciprocals, right? The product of any reciprocals is what? 1. These just cancel out. Anything times 1 is 1, and then I'm just left with 5, 6 times 1. Anything times 1 is itself. So for 46, looks pretty chunky, doesn't it? But what's actually the answer? 11/14, because multiply times 56 over 37 by cross-simplifying is all right here, right? 56, 56, or 56, 56, 37, 37, right? What's the answer to this one? This one's a little trickier. This one's a little trickier here. See if you can figure out how this could be here. But again, this is how it's presented. Where's the cross-simplifying actually occurring? What am I left with?
Is it cross simplifying the 3 and no, never mind.
Is the answer 3/5?
3/5. Right. Because again, I'm going to multiply by 41/28, right? Now, the 41s cross out, and And then the 28s, they're over here, they cross out, all I'm left with is the 3 and the 5. This numerator and this denominator. See how that worked? With the cross simplify and how that can be with things? It's kind of cool how it works. And again, it's highly relevant to what we're actually talking about right now. It's not so advanced that I don't think you understand what we just did here. But you can apply it. I mean, I don't know what they ask you in maps, or if you understand this concept. We actually do use cross simplifying for more things than just fractions. You'll have to wait till 8th grade, though, to kind of figure out what some of that stuff is, like polynomials. Yeah, then we'll use it. But you don't know what that is today, nor do you have to. But still, just understanding how it works. If you get it, if you understand what we did, if you're like, I can see how that works. You can really take some pretty hefty looking meaty problems and turn them into just nothing problems real fast. Right? Well, these were, now you see it though. Now you see it. Probably before we said anything, you would look at these and go, right? But now you see it. You see how it works. You see how I can cross simplify around it to make things easier for myself, to make the problem easier to solve. Okay. Any other questions? All right, we got what, 7-8 minutes, so don't, stay in